In this video, let's take a look at transformations of functions. So a parent function is the most basic form of a function. Let's write that down. So it's the most basic form of a function. And then what I'm going to do is I'm going to write out some examples in each of these boxes and give you like 4 different types of functions and what that box would look like with that word. So like parent functions, for example. Let's start with, let's say purple. So I'm going to write out absolute value. An absolute value function as a parent function would just be y equals the absolute value of x. Now let me grab another color. So let's say green is going to be exponential. So the parent function of an exponential function is we normally just write it as y equals 2 to the x power. 2 is the most basic, like base that we use for that one. And then quadratic would be y equals x squared. And then let's do rational is y equals 1 over x. So in each of these boxes, as we go through the notes, I'm going to repeat those types of functions with these transformation rules. So you may want to go ahead and like divide up these boxes into 4 sections, because that is what we're going to do as we go. Okay. So parent functions are the most basic form, and then we have things that happen to them. So a vertical shift is when you add or subtract a number outside of the grouping symbol. That's when you notice a vertical shift. So let's write that down. Add or subtract a number outside the grouping symbol. And the grouping symbol changes depending on the function. So we're going to take a look at those examples. Outside the grouping symbol. And we call it K a lot of times as an arbitrary way to represent the vertical shift. So we'll say positive K shifts our graph up, and a minus K shifts our graph down. Okay, so I'm not going to rewrite the word absolute value, exponential, quadratic, and rational, but just know in this top left box, this is still going to go with the absolute value function. But now we're going to add a vertical shift. So if I were to say, here, let me move this up. Y equals the absolute value of x let's just say plus k, then it goes up. Actually, I'm going to change it. I'm going to add an actual number. Let's say plus 2. So this shifts up 2, and then y equals the absolute value of x minus 2 would mean it shifts down 2. Okay, so for exponential, we'll do the same thing. So y equals 2 to the power of x, and then plus 2 would make it go up 2, and then y equals 2 to the x minus 2 would make this function go down 2. So just notice in each function the grouping symbol changes, but the rule stays the same. So y equals x squared plus 2 for quadratic makes it go up 2, and y equals x squared minus 2 will make it go down 2. And then for rational, the grouping symbol is in the fraction bar. So if we group it together, actually we're going to be outside the grouping symbol. So we need to put 1 over x plus 2 is outside, so it's like behind the fraction. And it could also be in front of the fraction. It doesn't have to be behind it every time. They just often write it that way, as long as the number is outside the grouping symbol. Okay, so those are vertical shifts. That is the rule. For a horizontal shift, you add or subtract a number inside the grouping symbol. So let's write that out. Add or subtract a number inside the grouping symbol. And this is the one that looks like opposite of what it's doing. So when you have positive h, it shifts your graph left that amount. And when you have a minus h, it shifts your graph right that amount. And then let's just keep using 2 for our example number here. So if I have y equals the absolute value of x minus 2 in the grouping symbol, it's going to go right 2. And if I have y equals absolute value of x plus 2 in the grouping symbol, it's going to go left 2. So the grouping symbol for absolute value is the absolute value bars. So for exponential, it's the exponent. So if we have y equals 2, and in the exponent we put x minus 2, it's going to make this function go right 2. And if we have y equals 2, and in the exponent we put x plus 2, it makes it go left 2. And then for a quadratic, it's going to be y equals x minus 2 in parentheses squared. And that makes it shift right 2. And then y equals x plus 2 in parentheses squared would make it shift left 2. And then for rational, that is the fraction bar. So x minus 2 would be in the denominator, and that would make this function go right 2. And then y equals 1 over x plus 2 would make it go left 2. So notice, like in each of those, the grouping symbol changes. But if the number is inside the grouping symbol, it makes it shift left or right, depending on the sign. And then the sign is kind of opposite of what we think. When it's positive, it goes left, and when it's negative, it goes right. All right, the next one says reflection over the x-axis. So that is when you have a negative sign out front of the whole function. Out front of the function. So that's all it is for a reflection over the x-axis. So y equals a negative absolute value of x is really all we have to write for that one. And then for exponential, y equals a negative 2 to the x. Let me put that one in the middle. And then, let's see, for quadratic, y equals negative x squared. And then for rational, it'd be y equals negative 1 over x. And the negative could be out front or in the numerator. Either one would be all right. For the next one, it says reflection over the y-axis. So that is when the input value is a negative. So like the variable, normally it's our x value. So instead of the y value, like the front of the function, it's the variable itself. So like for absolute value, it would look like y equals, and then the x that's inside there would be negative. For the exponential, it'd be y equals 2, and then that x is negative. So instead of the negative being out front of the entire function, it's inside the function. So for quadratic, it would be y equals negative x squared like that. And then for rational, y equals 1 over, and then like that x inside the function would be negative. All right, so for vertical stretch and compression, these go with the a value, we call it, that's out front of the function. So let's put a, because it could be another letter. They just normally call it that to keep things simple. So the a value in front of the function determines these things. So if the absolute value of a is greater than 1, you have a vertical stretch. Your graph will look more narrow, in other words. And if your absolute value of a is between 0 and 1, then you have a vertical compression. And your graph tends to look more wide with those. So it can depend on the function as to how much you can see when you have a vertical stretch or compression. Some of them are pretty obvious and some are not as obvious. So if we have the absolute value of x, like the a would be in the front, but let's give it a number. So let's say y equals 2 absolute value of x. This one would have a vertical stretch of 2. And then y equals 1/2 the absolute value of x. It has a vertical compression of 1/2. So for exponential, you'd say y equals, and then a number in the front. So let's say we have a 3 out front of the base. Then that would have a vertical stretch of 3. I'm just going to abbreviate since I don't have much room right there. Let me scoot that up a little. And then y equals, so if we had a decimal or a fraction, like let's say we have 0.7 times 2 to the x. That would be a vertical compression of 0.7 because that is like less than 1, but not 0. All right, and then quadratic. So if we have like y equals 2x squared, that has a vertical stretch of 2. And if we have y equals 1/2 x squared, again, that's a vertical compression of 1/2. And normally we say by a factor of 2 and by a factor of 1/2. I just don't have lots of room right there. But that's normally the way it is stated. So for rational, if I have a 2 in the numerator, that's considered a vertical stretch because it's normally a 1. So vertical stretch of 2. And the same thing for like if it's a decimal. So if I had 0.5 over x, that would be a vertical compression of 0.5. All right, so that is it for transformation rules of functions.